we are now going to tackle task 5. And we are given the graph of a piecewise function, and we want to write the rule. What they mean by rule is we want to write that equation for it. I want to write the equation for it. So to do that, I need to write the equation for each individual piece. So let's go ahead and let's start, and let's look at just this piece right here. And let's write that equation, and then we'll worry about those boundary points in a minute. So first, to write that equation, I can use y equals mx plus b because I know my b. I know my y-intercept is right there at 0. Now I need to determine my slope, my rise and run. So be careful of the scale. Here I'm counting by 1, 2, 1s. Here I'm also counting by 1s. So it looks like my slope is up 1 over 1, up 1 over 1. So my slope is 1. So my equation is y equals 1x plus 0, which we just write as y equals x. So there's for that little piece, that little pink piece. Now let's write the equation for this piece. Well, that piece in between there is just a straight horizontal line at 5. So that's my y. My y is 5. So the equation for that piece from here to here would be y equals 5. Okay, so for that piece, and then we have our last little piece over here, this guy up here. So now we need to write the equation for that. Go ahead and do that in red. So for that piece from here to here. So this one might be a little harder. We could use y equals mx plus b, but I don't know that b. So I'm going to use y minus y1, x minus x1, if we remember that one. Because I just need a point, and I do have a point. Like I've got 2 points. I've got the point 97 and the point 1510. So either one of those will work. So first I need to find the slope. So rise up 1 over 2, up 1. It looks like up 1 over 2. So my slope is 2. Oh, 1/2. Up 1 over 2. Y minus, I'm going to use 10. 1/2 x minus 15. Okay, so my equation, y minus 10 equals 1/2 x minus 15 halves. Add 10 to both sides. Y equals 1/2 x, negative 15 halves plus 10. I'm going to calculator that guy. Let's use parentheses. Negative 15 halves plus 10 gives me that, math, enter, 5 halves. So plus 5 halves. Okay, so there's for that last bit. So now let's go ahead and let's write this function. F of x equals, okay, the first bit there in blue, y equals x, comma. Now we need to look at the domain. So this purple bit, that pink bit, is going from an x of 0 up to an x of 5. So from 0 to 5, 0 less than x less than 5. And now I need to determine open dot, close dot. This is a closed dot here, and it's closed dot there as well, so we can include both of those. Equals 5. Okay. Now this next bit, it equals, my equation was just y equals 5, so we'll just use 5. And that was from 5 up until an x of 9. So 5 to 9. Now again, these cannot overlap. So the fact that I used an equal here tells me I can't use an equal here. And it doesn't matter because it's the same value at that point. That's a continuous point. It's where the one graph flows continuously into the other. There's no jump. So we're totally fine there. And then this one here has a closed dot there as well. So we would equal at the 9. Okay. And for the last bit there in orange, my equation is 1/2 x plus 5 halves. And that would be from 9 to 15. But there's an open dot here at that 9. So that can't be equal because, again, they can't overlap at that 9. And this is what we call a discontinuity. It's not continuous because it doesn't connect to the previous. It jumps up. So that's not continuous. So it is continuous right here. So let's go ahead and write that, continuous. But this jump right here makes it not continuous. So to make it continuous, you need each interval to match the other one. So like our step function that we talked about in the previous video is not continuous because you have to jump up to the next step each time. There's this jump. Okay, this one that we did in task 2 is not continuous because this one ends here but then jumps way down here. It has all these points of non-discontinuity right there. Okay, whereas this one is continuous because they match at their endpoints. They meet up each interval. Okay, so talking about continuity there. Okay, all right, so then we're just finishing up, sorry, this last equation. We have an open dot at that 9, so we don't have an equal sign there, but we have a closed dot at the 15, so we have an equal sign there. So that's that last bit, is to double check that domain and make sure that they don't overlap. What we mean by that is that since this one equals 9, this one can't. Since this one equals 5, this one can't. Okay, making sure you have that. Okay, all right, our last one, task 6 here. A shipping service charges are based on the weight of an envelope or package being sent. Write a function that models the situation and then graph the function. How much would it cost to mail an envelope that weighs 3.5 ounces? So envelopes up to 1 ounce are $1. Each additional ounce is another 21 cents. Okay, so basically anything from, and I'm gonna do this one slightly different. I'm gonna go ahead and kind of just do a number line. So the smallest package I could have is anywhere from 0 up to 1 ounce. Anything from 0 to 1 ounce is going to be $1. Okay. Anything from 1 ounces to 2 ounces is going to be an additional 21 cents. So it'll be $1.21. Anything from 2 ounces to 3 ounces is going to be an additional $1.21. So $1.42. Okay. So forth and so on. So now we can see how we would write that step function. So it would be $1 for anything in between 0 and 1 ounce. Okay, all the way up to 1 ounce. Now, do we equal 0? Well, if I have something that weighs 0 ounces, it's not going to exist. I wouldn't mail it. So no, we wouldn't equal 0 because there's no way for a letter to actually weigh 0 ounces. It'd be a partial ounce. So then it's going to cost me $1.21 for anything in between 1 and 2 ounces, including up to 2 ounces. But again, I can't include the 1, not equal, because I included the 1 here. Again, those can't overlap. Then it'll be $1.42 for anything in between 2 and 3 ounces, all the way up to 3 ounces, including 3. And then another 21 cents, so $1.63, anywhere from 3 to 4 ounces. And then dot, 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 so forth and so on. Those are what we call ellipses, okay? And they just continue it. So then it says graph it. So we want to graph this function. So let's come on in and we're going to do our axis. Okay. I'm going to go ahead and again step over by 2. 1, 2, 3. And then here, I don't know how we want to, do we want to do that same 1, 2, 3? Okay. Or do we want to, I think I want to space it out even more. Let's do every 4. 1, 2, 3. Just to give us more room because we're not even to 2 yet. Okay. So anywhere from 0 to 1, it's $1. So anywhere from 0 to 1, it's $1. Open dot here, close dot at 1. Okay. Anywhere from 1 to 2, it's $1.21. So here's $1.50. So $1.21 would be like here. So open dot there up to here. Anywhere from 2 to 3 is $1.42. So that'd be slightly under $1.50. So again, open dot, close dot. Anywhere from 3 to 4 is $1.63. So slightly more, open dot, close dot, so forth and so on. Okay, so there's how it looks. Then it says to how much would it cost to mail an envelope that weighs 3.5 ounces? Well, 3.5 is in between this 3 and 4 range. So it would be $1.63. So since 3.5 is in between that 3 and 4 range, f of 3.5 would be $1.63. Since it's less than 4.